Myself, Professor Satish B Thalange, Assistant Professor, Department of Civil Engineering. In today's session, we are going to study regarding the decision making under certainty, which is dealing with the problem transportation problem. Here, at the end of the session, students will be able to formulate the business problem in the linear programming and successfully able to apply the quantitative techniques analysis problems to solve the problems of the physical distribution of the products or commodity. Here, at the end of the session, the students is going to determine the schedule of the transportation with the minimum transportation cost. Let's start with the introduction. What is transportation problem? It is optimum allocation of the commodity or product from the various sources to the destination is nothing else the transportation problem. Means you are going to supply the commodity or the products from the various sources to the destination as per the requirement. Here, the main intention is what? In the transportation problem, the commodity should be supplied in such a way that there should be a minimum transportation cost. Means, finally, the objective is what? To determine the requirement within the plant capacity considering to the minimum transportation cost. Here, what are the basic content or the required contents for solving the transportation problems are what? The source with its availability, destination with the requirement, and the unit cost of transportation from various sources to the destination. Finally, you should keep in mind whatever the schedule is of the transportation you are going to make, there should be the minimum transportation cost. That is means what? Whatever the planning you are going to do regarding the supply to the demand, it should be with the minimum transportation cost. Here in this slide, there is a simple network representation of the transportation problem. Here the circular node with the orange color, they represents the sources, and the circular node with the purple color represents the destinations. Here there are m number of sources and the n number of destinations. You can supply the commodity or the products, or you can say also the raw material from the source 1 to the 1, 2 or n number of destination. The basic intention is what? Finally, to finalize or make a schedule of the transportation costs transportation with the minimum transportation cost. Here this is a payoff table, or this is a table which represent the particular transportation problem in the linear problem. Here S1, S2, S3 are the sources, and D1, D2, D3 and D4 are the destinations with their requirement as well as the availability. Availability is with the sources and the requirement is as of the each destinations. Now, before going to start the particular transportation problem solving, we should confirm whether the given problem is a balanced transportation problem or the unbalanced transportation problem. Here, the balanced transportation problem is nothing else when the particular demand is equal to supply, or the particular availability is equal to the requirement. And the unbalanced transportation problem is nothing else when the demand is not equal with the supply, and or when the availability is not equal to the requirement. In such condition, we have to go for the further step. When the unbalanced problem is there, we have to add the dummy rows or columns as per the requirement. Now, what is a feasible solution? A solution where the rows total of the allocation is equal to the availabilities and the column total is equal to the requirement is called a feasible solution. Now, these are the methods which are used for the solving the transportation problems after developing the particular transportation problem in the linear programming problem. There are three methods here: the northwest corner method, second is the least cost method, and third is the Vogel's approximations method. In today's lecture or the session, we are going to solve the particular transportation problem with the northwest corner. This is a simple transportation problem in the linear programming problem format. Here, the overall sources are defined its destinations are defined, the supply and the demand is also there. Now the first step is what? Whether we have to confirm the particular given problem is the a balanced transportation problem or the unbalanced transportation problem. How to finalize? Just make a summation of all the supply and the summation of all the demand. It should be equal. Here we see that when we make a summation of 7 plus 9 plus 18, it is 34, and when we make the summation of the demand, that is 5 plus 8 plus 7 plus 14, it is equal to 34. Means the particular given problem is of the balance type. We will move to the next first step. Here in the first step, as its name itself is the northwest corner, here in the table, the first corner, or you can say the northwest corner, I have shown it with the north and west. Here the 19 is the first cell with the payoff. Here the source 1, the supply is 7, and the demand, that is a D1, is 5. Now when the demand is 5, the supply is availability is 7, the overall demand is being satisfied. So the obtained next table will be what? As the D1 is satisfied, there is a column reduction of D1, and the newly obtained table is the of the D2, D3, D4 with the source S1, S2, S3. Now when we see this table, the availability, or you can say supply, with the S1 is 2, S2 is 9, and S3 is 18, and the demand, that is the each designations D2, D3, D4 is 8, 7, 14. Again, as with the northwest corner method, first of all we have to select the first cell with the northwest corner, that is of 30. Here the demand is of 8 and the source S1, the supply availability is 2. In this table we see that the particular demand is being satisfied by only 2, and the supply, that is totally is being supplied to the demand destination 2, and the availability of source with availability of the commodity or the product with the source 1 is 0. Now the total transportation cost for this step is 30 into 2, that is 60. The step 3, here after, as we have seen in the earlier step, the source 1, the availability of the commodity or the product is totally 0. Now there will be a row reduction, that is of S1, and the newly obtained table will be in such a way. Again, as the northwest corner method, we have to select the first northwest corner cell, which is having the transportation cost 30. Here when we see the cell of 30, the designation D2 is having the demand of 6, and the source S2 having the supply of 9. Means what? Whatever the demand of D2 is there, it is totally being satisfied by the source S2, which is represented in the present table, and the source S2 is having the ability of 3, and the D2 is totally been satisfied. That's why the transportation cost for this step is 30 into 6, because as the 6 units of the commodity or the product is being supplied from the source S2, and the total cost of transportation is 180. This is the first step. Here you observe that there is a column reduction, that is D2. Here, as I have shown in this table, the demand of all the D2 is being fulfilled by the source S2. That's why there is a column reduction, that is D2. Now this is the table where we see the first cell with the 40 payoff or the transportation cost, that is of the northwest corner. Here we see that the destination D3 is having the demand of 7, and the source S2 is availability of only 3. Means what? The destination of the D3 demand 7 is satisfied only by the 3. Now this is a table which shows the supply and the demand. Here we see that the total transportation cost is 40 into 3, that is 120 in the step 4. Now here this is a step 5 which is obtained from the step earlier step. Here when we see that the supply of S2 is totally been done, that's why there will be a row reduction, that is of S2. Now this is a newly obtained table. Here you observe that S2 is being reduced row. Now again, as with the northwest corner, the first cell is 70. Here the D3 is, the demand is of 4 and the supply of S3 is 18. Means what? The demand of D3 is totally being supplied by the S3 source, which is shown in the present slide. Now the demand is of 4 of the D3 has been 0 and the supply has been done by the S3 source, that is by quantity of 4. Now the total transportation cost is 7 into 4, that is 280 in this step. Now this is step 6. Here we see that only the one cell is available, that is of northwest corner, that is 20. Here the source availability is S3 is 14 and the demand is 14. It has been totally satisfied and the transportation cost is 20 into 14, that is 280. Now this is a table which is representing overall transportation cost of the each steps. The finally the cost is 1015. Okay. Now let me select the answer for the following questions. So you have selected these answers. These are the reference for the today's session. Thank you.